Hello, welcome to Astronautics for Exploit. This is Dr. Ayashola Ogundele. Application of digital twin technologies, dynamic replicable technologies designed to capture, map, and structure process variables. The focus points are importance of digital twin technology and applications of digital twin technology. Digital twin, a digital model of an intended or actual real-world physical product, system, or process that serves as an indistinguishable digital counterpart or fit for practical purposes such as simulation, integration, testing, monitoring, and maintenance is an underlying premise for product lifecycle management and exists throughout the entire lifecycle of the physical entity it represents. Nowadays, digital twin technologies are being applied in industries. Various applications are aerospace, manufacturing, automotive, energy and utilities, healthcare, transportation, medicine, smart cities, construction, government, retail and luxury goods, and infrastructure. In the aerospace industry, a digital twin of a spacecraft design is aiding spacecraft design, planning, manufacturing, launching, and in-orbit operation. Using Industry 4.0 digital twin technology, it is becoming much easier to build spacecraft that will survive in the space harsh environment. This helps to save money on research and development activities. In the healthcare industry, digital twins are being applied in the areas of surgery, training, organ donation, and risk reduction during surgery. They are also being used to measure people's flow through the hospital and track where the infection is and who may be at risk of contact. In the manufacturing industry, digital twin technologies are assisting to mimic unexpected spikes and dips in supply and to make the entire process smooth, to make construction more streamlined and productive while lowering the throughput time. In retail, digital twins are being used to model and enhance customer experience. In the e-commerce industry, digital twin is used to offer a variety of suggestions to customers by displaying how products look in real life. In the system management, they are helping to counter global climate change by creating more intelligent infrastructure, climate change monitoring, and emergency response plans. In smart cities, they help cities to become more environmentally, socially, and economically sustainable. Virtual models can guide planning decisions and provide solutions to many of the typical challenges modern cities face. Importance of digital twin technology. The digital twin technology, a technology of virtual replica of a physical object or system which is used to simulate, analyze, and optimize real-world behavior and performance, is helping to improve understanding of physical systems and predict how they will perform under different conditions. Data from the digital twin can be analyzed so as to predict when maintenance is required for a physical system. Illustration of medical imaging using digital twin is shown in this picture. Various applications of digital twin technologies are as follows: aerospace, manufacturing, automotive, energy and utilities, healthcare, transportation, medicine, smart cities, construction, government, retail and luxury goods, and infrastructure. Each of these applications is highlighted as follows. In aerospace, tasks are intrinsically complex, and its end products such as aircraft and spacecraft are expensive to design and build. And as a result, there is the need to get work done right the first time so as to avoid costly delays. In aerospace, from design and engineering all the way through to assembly and maintenance, digital twins improve decision making by allowing teams to visualize and interact with computer-aided design models and other datasets in real-time 3D. Computer rendering of Boeing 777-9X and 777-8X using the digital twin concept is shown in this picture. Uses of digital twin in aerospace are for product development and prototyping, simulation and training, maintenance and operations, sales and marketing. Using digital twin, 3D visualization enables designers, engineers, and other stakeholders to better collaborate and evaluate design and manufacturing alternatives for complex systems. Training experiences in interactive 3D or augmented or virtual reality enable better knowledge transfer and safer workplaces. Automation data analytics with 3D rendering of robots with digital visualization for big data is shown in this picture. Creating work instructions in mixed reality from as-built models from design and manufacturing can simplify and optimize inspection, maintenance, and repair activities. In sales and marketing, virtual showrooms, and 3D product configurators empower buyers to explore every variation of aircraft and make purchasing decisions more confidently. Boeing created an AI-powered aircraft inspection application using a digital twin of one of its planes. Various applications of AI and digital twins are shown in this picture. In manufacturing, digital twins are being used to increase efficiency. By creating a virtual replica of an industrial process, manufacturers can evaluate data faster, analyze performance trends over time, and optimize their operations. Digital twins are being used to monitor production line and to provide predictive maintenance guidance. Illustration of robots with AI capabilities and digital twin for space exploration is shown in this picture. Another application is in automotive. In the automotive industry, digital twins are being used in designing, manufacturing, and aftermarket services. Engineers can test numerous designs and select the most performing ones without developing a single physical prototype using a digital twin. Collaboration between AI robots and human beings is shown in this picture. Different use cases of digital twin in automotive are 3D car design and product development, human-machine interfaces, autonomous driving simulation, training and guidance, and sales and marketing. Illustration of digital twin technology is shown in this picture. Energy and utilities is another application of digital twin technology. Energy companies generate a wealth of data, especially as operations are increasingly outfitted with Internet of Things sensors, high-definition cameras with artificial intelligence capabilities, and more. Digital technologies, for example, real-time 3D, is helping to visualize energy data to provide right-time insights, better informing decisions. The picture here shows remote monitoring of patient health via digital twin technology. Different use cases of digital twin in energy are design visualization and collaboration, learning, training and safety, field service, site operations and maintenance, medical imaging using digital twin is shown in this picture. In healthcare, digital twin technology help with enhancement of patient care, system optimization, proper training, and to create virtual representation of medical devices. The use of digital twin technology in diagnosis process allows healthcare professionals to simulate different scenarios and identify potential issues without disrupting the patient's actual care. The picture here shows virtual space, a digital twin of the real space. Transportation is another application of digital twin technologies. Digital twin technology is used to create virtual models of transportation systems such as roads, bridges, and trains. These digital twins are used to simulate the behavior of these systems in different scenarios, such as traffic congestion, weather condition, and maintenance events. The technologies help to provide real-time information to drivers. Interrelationship between Internet of Things, data analytics, machine learning, and digital twin is shown in this picture. Medicine is another application of digital twin technology. Digital twins is being used for medical education and training purposes. For medical students to interact with the virtual replica of the human body It helps them to explore its intricacies and practice complex procedures without any risk. Digital twins is contributing to medical research. By studying the functional models, scientists can gain insights into disease progression, test new hypotheses, and accelerate the development of innovative treatments. Illustration of digital twin of Earth is shown in this picture. Smart city is another application of digital twin technologies. A smart city is an urban environment where technology, data, and connectivity combine to enhance the quality of life of its residents. It also focuses on optimizing resource management and improving sustainability. Digital twin of a smart city is being used to simulate and analyze different scenarios, such as traffic flow. Digital twin of the Earth as proposed by Destin E is shown in this picture. Construction. Digital twin and AI technology allow the construction industry to optimize project data, streamline collaboration, and better visualize projects from design through to operations and maintenance. By using AI to bring valuable data to the field, contractors can capture and communicate design errors. Digital twin in healthcare is shown in this picture. Government also make use of digital twin technology. Digital twin is helping government agencies and contractors to make informed and quick decisions. It enhances quality, reliability, and speed of production and service delivery by the government, using extended reality to empower users with all the information they need. Digital twins help government to bring job-critical learning and training into immersive 3D. Illustration of digital twin system is shown in this picture. Infrastructure is another application. Digital twin technology helps builders, planners, and operators across cities worldwide better understand and optimize the spaces for public use. By using advanced interactive models and live IoT data, stakeholders can simulate traffic flow. Illustration of digital twin technology is shown in this picture. Infrastructure. Different use cases of digital twin infrastructure are combine and visualize key data sets, simulate mobility and usage patterns, and improve sustainability outcomes. Use of digital twin technologies in additive manufacturing is shown in this picture. In retail and luxury goods, digital twins is helping to improve various aspects of the customer experience and store operations. Retailers are using digital twin technology to optimize their supply chain operations, such as determining the most efficient shipping routes and identify potential bottlenecks. Disease modeling and epidemic management using digital twin is shown in this picture. Use cases of digital twin in luxury goods are real-time 3D product configurators, photorealistic marketing imagery, virtual try-on experiences, and virtual showrooms. Simulation of an invasive clinical procedure using digital twin solution is shown in this picture. For more information, contact Astronautics for Exploit. You've been watching and listening to Application of Digital Twin Technologies, Dynamic Replicable Technologies designed to capture, map, and structure process variables, presented by Dr. Anyashola Ogundele, with the focus points Importance of digital twin technology and applications of digital twin technology. Thank you.